A right circular cone of height h is cut by a plane parallel to the base and at a distance h by 3 from the base. Then the volume of the resulting cone and frustum are in the ratio. So we are given that there is a cone like this. Okay. This is the height and this is the radius. Alright, so this is h, this is r. And we are told that this cone is cut by a plane parallel to the base. So this is the base, right? This is the base and parallel to this and distance of h by 3 from the base. So distance of h by 3 from the base, this cone is cut. Okay, this cone is cut like this. Alright, at a distance h by 3 from the base. Then the volume of the resulting cone and the frustum are in the ratio of what? So after cutting this, what do we get? We get two things. We get a resulting cone which will be like this. All right, and we'll get a frustum which would look like this. This is the frustum, and we are asked what is the ratio between the ratio of volume of these two things. So the volume of this resulting cone is to the volume of this frustum. This is what we are asked by the question. All right, so how do we proceed now? Now let's say the radius of this resulting cone is capital R. All right, then what will be the height here? It will be, now this total height is h. All right, this total height is h and this height is h by 3. Then what will this height here will be? It will be h minus h by 3. So h minus h by 3 will get 3 minus 1, 2 by 3 h. So the height of this cone here will be 2 by 3 h. Okay, so the ratio radius is capital R and height is 2 by 3 h. Talking about the frustum, height is h by 3, right? Because from the base at the distance of h by 3 we have cut this, so this height here will be h by 3 only, and the radius is the same as that of cone, which is r, small r. Now in order to get this volume of okay, so we know the formula to calculate the volume of this cone. Okay, but there is no standard formula to calculate the volume of this frustum, right? We can calculate the volume of this cone by using the formula, but we don't know how to calculate the volume of this frustum. So what we'll do is, in order to get the volume of the frustum, what we'll do is get the volume of this bigger cone, get the volume of this cone, right, and subtract this volume of the resulting cone from this. Okay, volume of the resulting cone, will subtract it from volume of the bigger cone. All right, and after that we'll get the volume of this frustum. Okay, so this much is clear. So first of all, let's find out the volume of the cone here. So volume of the cone will be, let's recall the formula to calculate the volume of the cone. It is 1 by 3 pi r square h. All right, now here r is r only and h is this whole thing. So this is the formula for volume of cone. Now what will be the volume of the resulting cone here? Volume of the resulting cone will be okay, so it will be again 1 by 3 pi r. Instead of r we'll write capital R, pi capital R square, and instead of h we'll write 2 by 3 h. Now what is this capital R? Okay, now I'll divert a little bit from this question and let's talk about this right angle triangle here. Okay, let's talk about this right angle triangle here. I'll draw it separately over here. So this is the right angle triangle. It is A, let's name this ABC, and we have cut this triangle in half from here. Okay, not in half but at a distance of h by 3 from here, and this is again a right angle triangle. Let's name it PQ. Okay, this is P, this is Q. So we have two triangles here, triangle ABC and triangle APQ. So distance of BC here is small r, PQ here is capital R. Okay, we have named it as capital R. This entire height is h and this height here is 2h by 3. All right, this is 2 by 3 h. Okay, now if we recall the teachings from the chapter of similarities, in similarities what we are told is that whenever there are two similar triangles, the ratio of the heights in similar triangles, the ratio of the heights are equal to the ratio of the bases. Okay, of the bases. We have learned this in the school. The formula would look something like this: h1 by h2 is equals to b1 by b2, right? I hope you can recall this. We have learned this in the school. So using this, we can find out the value of r here. So let's write it down. We have, instead of h1, we'll write this h over, instead of h2, we'll write 2h by 3. So 2h by 3, and this 3 will go in the numerator and gets multiplied with h. So we have 3h upon 2h is equals to, b1 here will be r, small r, and b2 here will be capital R. We need the value of this capital R. So what will the capital R here will be? It will be h cancel. R will go on the left hand side. So we get R is equals to 2 small r by 3. So we have the value of R, which is 2r, 2 small r by 3. So let's substitute it over here. So we get 1 by 3 pi, instead of r will write 2 by 3 r whole square, because this is capital R square. So whole square into 2 by 3 h. Okay, so I hope this concept, I hope you have understood this concept. So I'll just erase it. Okay, if you want to copy it down, you can pause the video and do it, and I'll just erase it because I don't have space here. So I just hope you have understood this, right? So let's erase this. So now we have volume of resulting cone as 1 by 3. So I'll write it here. I have 1 by 3 pi, and we'll open this up. So 2 square is 4, r square upon 3 square is 9 into 2 by 3 h. Okay, now what we'll do is, we know in volume of the cone we have pi r square h. Okay, here again we have pi r square h. All right, so instead of making this too complicated, what we'll do is write, let pi r square h as t. We'll write pi r square h as t. Okay, this will make our job a little bit easier. Okay, so we have volume of cone as 1 by 3 t, because we are writing pi r square as t. So 1 by 3 t, and we have 1 by, okay, so in denominator we have 3 3s are 9, 9 9s are 81. So in denominator we have 81. In the numerator we have 4 2s are 8, and instead of pi r square h, we'll write t. Okay, so volume of the cone is 1 by 3t. Volume of resulting cone is 8t by 81. So from this we can calculate the volume of frustum here. So what will be the volume of frustum? It will be volume of cone, which is 1 by 3t, minus volume of resulting cone, which is 8t by 81. Let's take the LCM as 81. Now 3 2s are 6 and 3 7s are 21. Yeah, and this is t minus 8t. So we have 27 minus 8 will give me 19t upon 81, right? So we have the volume of frustum here, which is 19t by 81, and we are asked, then the volume of the resulting cone and frustum are in the ratio of what? So volume of the resulting cone here is this, like, right? Volume of resulting cone is 8t by 81 is to volume of frustum we have just calculated. It is 19t by 81. So 81 cancel, t cancel. So we are left with 8 is to 19, and this is our required answer. So here option B is the correct one.